Hello everyone. Thanks for joining our webinar series on end-to-end exactly once. My name is Hitesh Kapoor. I am an engineer at DataTorrent. And joining us on the webinar is Ajay Gupta, who will be actually delivering this talk. He is a contributor with Apache Apex and also a software engineer at DataTorrent. Before we move ahead, could you all please give me a hands up if you could hear the audio or even ask any question or stuff, so that we are sure that you can hear us. Yeah, I see some hands going up. Thank you for that. Thank you for that. Uh, okay, so here are some logistics regarding the webinar. This webinar is being recorded. It will be available after the session has ended. To watch again and share with your colleagues who are not able to attend our session today, you can redirect to that link and stuff. The presentation will be available on SlideShare. Also, if you have any questions during the session, you can directly submit the questions via the question tab in your console. We'll be happy to answer them as they come up, or we can even answer them at the end of the session, whichever is the logical point to do that. So without further ado, I will hand it over to Ajay Gupta.
Okay, hello everyone. So I am Ajay, and today I will be presenting this talk on end-to-end exactly once in Apache Apex. So first of all, I would like to thank you all for deciding to attend this webinar. So in case there are any questions, please feel to ask them via the questions tab. So let's start with the presentation. Okay, so this would be the agenda for this webinar. First, I would like to cover some introduction regarding Apache Apex. Post that, we will see how Apache Apex ensures fault tolerance, considering that it is actually running on a distributed system. Post that, we will see idempotency in Apache Apex. And then we would move on to end-to-end exactly once. So actually speaking, fault tolerance and idempotency help us achieve help us achieve end-to-end exactly once, and so I am covering them before this one, and post that we'll move to questions in case there are any. I would also be taking breaks between the slides, so that in case there are any questions in between, feel free to ask them and I would be happy to answer them. Okay, so Apache Apex. So basically Apex is a in-memory distributed stream processing platform. So it actually makes it extremely easy to actually write applications for streaming data. So basically how the applications are written is that the application logic is broken down into smaller components, which are in Apex terms, they are called operators. And these operators, basically each of these operator instances run on different nodes in a distributed system. So basically this entire all of these operators together, since they are running together, they ensure that your application logic is basically the data flows through all of these operators, and your application logic gets performed correctly. So Apex provides an extremely natural programming model. So we provide support for mainly we provide support with Java, but we also provide support with Python, and we are actively working for providing support with Python as well, Python, and we provide support for Scala as well. So at the same time, we also support maintenance of metrics. Basically, when we are actually running this application in a distributed system, we would like to see the metrics for our system, and hence it actually becomes important. So we do support all of those as well. Apex is extremely highly scalable and low latencies, and provides extremely low latency for the operations which are to be performed. So basically the operators can be scaled up or down. So if you have, suppose, 5 operators in your application, and so in case some operator is for some reason performing slow, so it might be performing some heavy operation, right? So we can Apex can actually determine that it is performing slow, and it can actually replicate more instances of this operator, so that the load gets distributed among all of these operators, and we can actually achieve the SLA which we have promised, right? So and it is this is one of the probably one of the most extremely useful features for Apex. Apart from that, we also provide fault tolerance and correctness. So this is also extremely important, considering that we are actually running in a distributed system, and nodes can actually go down at any point of time, and hence it becomes important that we are able to recover from those from these failures, and able to start processing without the user noticing any kind of failure. So basically, and because it is fault tolerant, this feature also helps us achieve to some extent end-to-end exactly once as well. So we achieve fault tolerance by means of checkpointing, which we'll cover in a few slides. Apart from that, Apex also provides operability. So operability in the sense that since we are actually running on the distributed system, we would like to see all of these system metrics and system and the application metrics, basically how the application is performing, and so that we are assured that our application is running fine. By viewing these metrics, we can actually view them as graphs, and as well as record all of these metrics. So, and considering that these metrics can actually change dynamically, it actually becomes extremely important that these metrics are available to the user. Okay, so as a company, DataTorrent, what is our vision? So if we actually see, big data is, and the current situation, it is not very well productized, and the products, even the products which are available, they don't provide a high level of operability. So when we actually as an enterprise look at what we want to achieve for our customers, we actually look at the total cost of ownership. So, and when we view total cost of ownership, it includes basically three parameters: time to develop, time to launch, and the cost of ongoing operations. So what do we mean by time to develop? It is basically the amount of time taken to develop our application. So we would like to reduce this, as well as once the application has been developed, how much time does it take to actually move it into a production environment, and then post that, once the application is in production, what would be the cost of maintaining this application? So all of these together becomes the cost of ownership, what we envision over here. So as a company, we would like to provide an application wherein we are able to provide our customers with simple interfaces, or probably with pre-built apps, or reusable code, so that the time to develop actually becomes extremely less. Then we actually want to provide a product wherein it becomes extremely easy to debug our code in case there are any issues, which actually helps us ensure that the time to launch, as well as the the cost of operations once it is launched, are extremely less. So at the same time, we also want to ensure that the users are able to visualize and manage all of these, and manage the application via by seeing the metrics as well as the data itself, which they want to see in the application, so that it would help them ensure that their application is running fine. So these are the parameters which DataTorrent vision is looking at. Okay, so what are the next gen big data applications which we feel are the future of in the big data, right? So considering that we are reading with big data, there could be many IoT related applications which are actually sending sensor data or there could be some service wherein we are actually writing logs to Kafka in a distributed system, or we might be reading data from files, or probably there might be we might be reading data from Twitter or Facebook, or some other social media, right? So these actually form the different data sources for the big data, right? And each of these data is actually streaming data, which is unbounded, and it is continuously coming in with high speed and high velocity. So and at the same time, we would like to actually process all of this incoming data, probably perform some transformation, or probably load it to some other application wherein we might actually want to do some analysis, or probably load it into a database for further as a data warehouse or something like that. So the uh, mainly the Apex actually provides an uh, extremely good support for such ETL related operations. So considering that we are running in a distributed system, we would also like to process all of the data in memory, and which actually is important because we are dealing with streaming data over here, and hence it is best to avoid making use of this. So by making use of the distributed system here, we are able to ensure that we are processing all of the data in memory. And also we would also uh, like to provide support for stateful operations, like uh, despite being running in a distributed system, we would like to ensure that users are able to support operations, many different operations like aggregation, or probably do some analytics related stuff. So this is the basically the overall picture of big data applications which we envision would be the future of big data. So how does DataTorrent actually fits in this big data ecosystem? So like I said, we have different data sources like sensor data or social media, uh, etc. And probably we may have some different file systems or different queuing systems like Kafka or S3 or Rabbit Message Queue, or other systems like databases. So from all of these systems, basically the data sources might probably send the data to such Amazon or Kafka or such stuff, and then from there we can probably read the data via Apache Apex and perform some transformations and all of those stuff over there. So if we actually say Apex actually sits on top of Hadoop, and we support many different flavors of Hadoop like Mappa, Hortonworks, Cloudera, as well as the native default the Apache Hadoop, and yeah, so we can actually perform some operations and probably then view them. We may want to have a real-time analytics view, or we may want to perform some analytics, or probably have like to see all of the data in real time, basically some sort of aggregations and dimension computations, and probably we may want to see that data in real time. Or probably if nothing else, we may probably want to store it in the database, or probably on the HDFS. Yeah, so this is how the stack for Apache Apex and DataTorrent looks like. So at the base, we have the Hadoop, which is the operating system. Basically, it is a distributed operating system, which we support Apex. Basically, Apex runs on Hadoop 2.2 and later. So at the top of that, we have the Apex core engine, basically, which ensures that our basically the application is running fine in the distributed environment. Uh, it is yeah, and on top of that we have the Malhar operator library. So this is basically this is a list of this is an operator library probably containing around 350 to 400 different operators related to transformation, probably reading data and writing data to databases, performing some analytics, or uh, probably reading from Kafka and other such stuff. So these are pre-built operators which the user can directly use. Apart from that, if the user uh, has some other application wherein these pre-built operators are not able to provide him uh, with his logic, so we have provided higher level APIs wherein using which the user can actually write his own operator and use them in his application. We also support batch, and we are actively working on making it a lot more easier for providing for running batch operations as well. So this now, if we see this library actually makes the development work a lot more easier. Apart from that, if we go one level higher, we have these application templates. So these application templates are actually pre-built applications itself, you can say. So some of the applications like Kafka to SDFS, or if we want to move, wherein we move data from Kafka to SDFS, but and we may want to perform some operations in between, or probably if we want to move the data from HDFS to SDFS, or from JDBC to SDFS, or from JDBC. So these are some of the applications which we have open sourced, and so the users are free to use them, and as well as download the source code and play around with it. So this actually makes it a lot more easier for the user to understand how the code is to be written, and how the operators are to be used in their application. Then on top of that, if you see, we have our the enterprise version for the DataTorrent, wherein so over here we provide support for basically visualization stuff, wherein we can actually see the graphs, or the graphs for the data which is actually flowing through us, the streaming data which is actually flowing through the system, or probably we also provide support for monitoring and management, wherein basically we can easily submit our applications to run on the Apex platform, as well as easily monitor all of these applications, view the different system metrics as well. Apart from that, we also provide a GUI based application assembly, wherein the user can actually simply drag and drop the operators, basically connect all of these operators, and ensure that his application is the application is formed simply by drag and drop feature. So and making some configurations for these operators, and your application is gets built. So this layer actually makes it extremely easy for makes it a lot more easier for developing the Apex application and monitoring it as well. So yeah, this is the application development model. So there are basically speaking, there are two concepts when we are writing an Apex application. We have the operators, and then we have the stream. So the data is flowing as a stream. So if you actually see, we have this operator over here. So probably this operator might be reading data from different sources. Probably let's assume Kafka. So this operator is reading data from Kafka. So after reading, it sends data to this operator via stream. So so this is the stream, and the tuples are flowing by this stream to this operator. So and this operator might be doing some filtering operation, and probably sending this data to two different operators based on some condition. So and then these two operators might be using some library, or probably enriching the data, and this operator might be taking the data from these two operators and performing some operation, and probably the last operator could be probably sending it to some other system via some external source, or probably writing it to database or SDFS, some operation, right? So if we actually see, we can actually output data to multiple operators, as well as read data from multiple operators. At the same time, if we see the same operator instance, we can have multiple copies of the same operator instance, to ensure that we are able to distribute the load in case there is heavy load on this operator. So yeah, so yeah, so this is how basically the application is built as a directed or cyclic graph. So yeah, so actually speaking, we are also now providing support for loops in this, by making use of an operator called delay operator. So yeah, that is also one of the features. Yeah. So how does Apex actually integrate with Hadoop or Yarn, we can say? So suppose that we have 4 different nodes over here. So we have right. So each of these boxes inside these nodes is actually representing a container. So like we see, we are actually having some jobs which are actually map reduce based. So by showing that, we actually want to indicate that Apex actually does not basically Apex does not mind even if there are other applications like map reduce which are running on the cluster. So Apex runs independently, irrespective of the other applications running on the cluster, right? So so how does Apex actually start, right? So once the client actually submits the application, so what happens is that we actually request the resource manager to to allocate us a single container. So in this single container, we actually run this STRAM. So STRAM is basically the application master for Apex, so which actually ensures that the overall application is running fine. So once this STRAM gets started on one container, this STRAM would then ask, which would have actually read, it would have read the application DAG which would have submitted, and this application DAG, after reading this application DAG, STRAM would request the resource manager for more containers so that it can actually schedule each of these operators on different containers. So in this case, STRAM would have actually requested 5 containers. So actually, if we see, there are 6 operators which are running. So in this case, the 4th and the 6th one, they're actually running on the same container. So this is probably another feature in Apex wherein you can actually run the multiple operators in the same container as well. So after requesting these containers, once all the containers have been allocated, STRAM would then start the application and the data can start flowing from one operator to another. So before actually moving ahead, I would like to take a pause for any questions. So please do feel free to ask questions via the questions tab, and I would wait for a minute or two for them. Okay. So one of the questions is, how is it different from how is Apex different from Apache Spark, right? So in a way, like if you actually look at the overall picture, somewhat it is the same, but there is one of the extremely important points over here is Spark is actually not truly a streaming platform. So how Spark runs is that it actually uh, takes the data as micro batches, and then it runs basically in our case, which we say operators, right? So this operator, basically the application logic is run on these micro batches and not on a single tuple as such. So if you actually see, this can actually introduce latency in our application, because Spark waits to form such micro batches and then only sends this data from one part of the logic to another part of the application logic. So in a way, it is not a probably not a truly true streaming platform, I would say. Okay, there is another question about how does it compare to Flink. So okay, and uh, another subsequent question is, how is there a Scala interpreter for Apex? So regarding the Scala interpreter, yes, there is a Scala interpreter. So if you actually search on if you actually go to the DataTorrent website and search in the blogs, we actually have one of the blogs which actually explains how you can make use of Scala for writing Apex applications. And regarding Apache Flink, it is also a truly streaming platform that I would not deny. It is it is a lot similar to Apex in that sense, and but where we actually differentiate, I believe, is that we have actually come from an enterprise edition, whereas Flink was more of a, it has actually come from a university-based uh, from university. So our founders are basically actually have worked in Yahoo in the Hadoop ecosystem, and they have then come up with this Apex ecosystem, and yeah, and um, apart from that, where we excel, I believe, over Flink is that um, we uh, the operability features which we are able to provide, I believe, are a lot better than Flink. Okay, I guess there are no more questions, so I would move ahead with the presentation. So let's move on to fault tolerance. So like I said, machine failures are extremely common in a distributed system. So does it actually make sense to process the entire stream again? Right? So we cannot process, right? Because probably the data might have actually been lost. We might have been running our application since probably days and probably weeks, and we cannot actually process all of these data again from our system. So what do we do in that case? So we would like to probably checkpoint and probably recover from that state, right? So Apex just provide the feature of checkpointing and ensures that there is no loss of data, as well as ensures that there is no loss of the computation state as well. So since considering that these operators are running in the different in a distributed system, we would like to ensure that when these operators actually come back after failure, they have not actually lost their state. Basically, they are in the same state as they were before failure. So apart from that, we also have a concept called buffer server. I would actually take it up in the future slides, so we'll talk about it at that time itself. Okay, so before actually, I would actually take checkpointing and windowing in somewhat the same in the same way, right? So okay, so first let me cover windowing. So when we actually speak of an of the streaming data which is coming to our system, how Apex deals with this is that it actually you can say it simply assigns each of the tuple a window ID. So if you actually see over here, this is the data which is coming in. So this is the oldest data you can see, and this is the newest data. So over here, what Apex does is that it inserts some additional control tuples like begin window and end window. So all of these tuples form a part of this window. So you can say that these begin window and end window are tuples are actually inserted every half a millisecond or so, and so these tuples form a part of this window, right? So and every probably say about 20 to 30 windows, we actually insert a checkpoint control tuple as well. So at this point of time, we actually store the state of the different state of the operator. So like when an operator receives this tuple, the operator state is stored into the memory of SDFS, which actually helps us ensure that we are able to recover in case there is a failure in future. So so for example, if we suppose that we have a simple count operator which is maintaining the total count of the number of tuples which have come in. So it would have actually counted, say, suppose lakhs of records, right? So the current count might be probably 1 million, and if at this point of time this operator fails and if it has to be recovered back, so this actually we would like to continue counting from 1 million itself, right? So this is the state of that operator, we can say. So this state is periodically checkpointed by Apex. So also so since we are actually dealing with the application itself, right? So it could be the case that the downstream operators in our application are actually lagging behind than the upstream operators, because probably the downstream operators might be performing some heavy tasks and might be a bit slow. So in that case, if any of the upstream operator dies, we want to ensure that the downstream operators basically we want to ensure that there is no data loss in case there is a failure, right? So in that case, the platform decides the window ID from which an operator should restart in case there is a failure. So I would actually cover this topic in the next slide, so we'll look at that time. Also, the state of the STAM is also checkpointed, since STAM is also basically a process which is running on one of the containers, so it can also fail, right? So its state is also checkpointed so that the application can recover from from that state itself when it comes back alive. Also, another point to note is that no data is checkpointed. So basically, the data output is never checkpointed. It would again. So yeah, probably. Yeah. So suppose that we have an application with 5 operators. So this is our application, and suppose that we are performing checkpointing every 20 windows, right? So assume that the operator O1 was probably reading some data and its current window ID. So currently it is at window ID 125, and hence its checkpointed state would be at 120. Similarly, O2, let's assume that O2 is currently at window ID 110, and its checkpointed state would be at 100. O3 is at 105, and its checkpointed state is 100. O4 is at let's assume at window ID 92, and hence its checkpointed state would be at 80, and O5 is at window ID 77, and hence its checkpointed state would be at window ID 60. So now let's assume that this operator O3 gets killed, right? So at this point of state, the operator O3 gets killed. So how does Apex handle this? So what Apex does is that it once it determines that this operator is no longer performing, so it would actually undeploy this operator, the operator O4 and O5 as well. So undeploy, and after undeploying, it would redeploy all of these operators O3, O4, and O5. Also, if we actually see the last checkpointed state for O5 is at 60, right? So to ensure that there is consistency in the application, all of these 3 operators O3, O4, and O5 will actually start from window ID 61, basically the window ID after the last checkpoint. So after the application has started, this would be the window ID from where the processing would start again. So now another question which arises is that since O3 is at window ID 61, right? So from where would O3 actually get the data for this window ID 61? Because O2 is now actually at window ID 110, right? So this is where the concept of buffer server kicks in. So buffer server is actually a publisher subscriber based message queue which actually resides between all of these operators. So between O2 and O2 there would be a buffer server. Similarly, between O2 and O3, O3 and O4, and so on. So so what is buffer? It is a pub/sub message queue, and we can actually, and in case there is a overflow, we would actually spool the data to the disk. So what happens is that now O2 will actually keep publishing its data, its output to this buffer server. So now this buffer server would actually have the data from for the different window IDs. So it would also contain data for window ID 61 till window ID 109 in this case. So now O3 just has to actually, when it subscribes, it can actually read the data from window ID 61 itself, and hence there is no loss of data. So it can actually start reading data from window ID 61 and move ahead with processing. So now O3, O4, and O5 all would have data for the window ID 61. Okay, so now if we actually see, since we are actually ensuring that since we have actually moved back a state, we are ensuring that there would be no data loss, right? Because even if an operator fails, it can actually move back, and it ensures that all of the data which it needs to read and process actually gets processed in this case. So in a way, Apex actually by default, Apex would support exactly at least once. So that is, each of the input tuple will get processed through the entire application at least once. So in this case, yes, there can be possible duplicates, and but it ensures that there is no missing data. So all the input records would get processed, and yeah, this is ensured by bringing the operator back to the to a checkpointed state, a checkpointed consistent state, and by making use of the buffer server, we can actually replay the all of the windows where which were actually lost when we actually when one of the operators actually failed. So okay, actually before moving ahead, I would like to take any further questions in case there are related to fault tolerance or Apex. So please do post your questions via the questions tab. Okay, I guess there are no questions, so I would move ahead. In case there are any, yeah, please do feel free to post them. So, okay, so okay, let's move to the next concept for idempotency. So, what does idempotency mean for Apache Apex? So, for Apex, it simply means that if we should actually replay the same data which was played. So in case there is a failure, we would like our operator to replay the same data as it had played before failure. So, so suppose that if an operator had processed, let's say 100 windows, and now it fails at window ID 100. So, and suppose that it now actually has to start processing from window ID 80, right? So between 80 and 100, it would have actually already sent this data, data for windows 80 and 100, right? So for each of these windows, there was some data set X which was sent. So after recovery, we would like to ensure that again, when these windows are replayed, the same data is sent. Right? So this is what we mean by idempotency. So if we actually see when we store data in the buffer server, we actually store some meta information as well regarding the tuple. So which actually indicates the window ID to which it belongs. So with that, we are actually able to ensure that when we recover back from a failure, we would read data only which was required to be read in that window ID, and hence the output data is also consistent since we have read the data, since we have only read the data which was to be read in that window. So why is idempotency important? Right. So I would probably take it with some this example. So assume that this max operator and the console operator are the last two operators in our application bag. So the max operator is basically, after reading every tuple, it is probably simply emitting the max it has seen up till now, and the console operator is simply outputting that the maximum value which it has which was emitted by the max operator. So so let's assume that this was the data which was received by max operator in window ID 80 and window ID 81. So also let's assume that this max operator dies while processing the window ID 81, and assume that it recovers, the application decides to recover it back from window ID 80, right? So assume that there was no idempotency. So it could be possible that this max operator could, since there is no idempotency, right? So it might assume that this value 45, which actually was to be processed in window ID 81, it could assume that it had actually got processed in window ID 80, and so it would actually not process that data itself and simply move to the data 32, right? So in that case, if we see the data, the output itself by the max operator would be wrong, wherein it would actually emit a max value of 32, whereas it should have actually emitted a value of 45 in case there was no failure. So so this is where idempotency becomes important, so that the same data gets replayed and the data which is actually output is correct. Right? Yeah. So let's move to end-to-end exactly once. Right? So truly speaking, there is no distributed system which can actually say that we support strictly exactly once. So basically, that is why even Apex says that we support exactly once from end to end. Basically, your entire application as a single unit can support end-to-end exactly once, and each of the single operators could actually emit or probably process the data uh, at least once, right? So why is end-to-end exactly once important? So it is important when we are actually dealing with external systems like databases. So wherein we would actually want to ensure that each of the transactions or probably each of the operations which would perform on the operator, there are no duplicate operations which are performed with databases. So end-to-end exactly once is basically the data should neither be duplicated nor should any of the data values be lost, right? Uh, so in this case, like I said, the platform support for at least once is a must because we would not like to lose the data, right? In case of Apache Apex, how do we support exactly once? We want our platform to support at least once. We want the platform to support idempotency, and we want and at the same time, there is another concept for operator logic. So when we are actually dealing with these external systems like databases, uh, these operators which are actually dealing need to have some kind of a logic using which we are able to ensure end-to-end exactly once. So we have actually already covered at least once, right? And as well as we have covered the importance of idempotency and how buffer server is useful for ensuring idempotency. So let us move to see uh, operator logic is implemented. Right? So let us see for first we would see the operator logic for output operators. So like an operator for let's say for databases. So something like a database output operator. So if you actually consider databases do support transactions, right? So what Apex does is that so suppose that we are performing some writing some data into the database. So we are inserting some in each window we are reading some data, and probably we are inserting those records in the database. So along with inserting these records, what Apex does is that it stores some meta information in uh, another table called metadata, right? So this by storing this information in a metadata, we are able to ensure that when in case there is a failure and in case some windows need to be replayed, we can actually check this metadata table in the database itself, and uh, which would actually contain information that okay, these windows were already processed, and so you are not required to insert these records again. So hence this ensures that there won't be any duplication in case there is a failure and there is a replay of data. So let us see with this diagram itself. So suppose that there was we have the database output operator and it performed some checkpoint over here, right? So now we are processing some windows, and at suppose that we have processed data till window n. So all the records up to window n have been inserted in the record in the database. So now let us suppose that we are processing window ID n+1. So how would the processing begin, right? So what we do is that before we start processing the window, we actually send a begin transaction to the database. Then when we actually start reading the records, we would keep inserting the records in the database, and once the window has ended, at the end of the window, we would insert in the meta table the information that for this operator we have processed data till window ID n+1, right? So and post this we fire the commit operation. So once the commit is done, right, so the data in the data table would also be committed as well as the data in the meta table would be committed. So both of these operations would be concurrent in the database. So this ensures that in case the data is replayed, we actually have information in the database that we have processed window ID n, and this doesn't needs to be replayed. So now if you actually consider this, we also need to ensure that the input data which is actually coming is idempotent. That is, there is no different data across the windows. So, why is this operator logic important? So let us take this example and have a look at it. So assume that we are reading data from Kafka, and suppose that Kafka is actually reading the data and emitting some numbers, and we are outputting these numbers to the database output via the database output operator. So let us assume the same scenario again, wherein in window ID 80 these were the data tuples, and suppose that in case there was okay, so actually this concept is more related to how we would deal for idempotency for operators, right? So if you actually consider an input operator, right? We don't have any buffer server for that case. So when we between this operator and this operator, we will be having a buffer server. But what about this Kafka input operator, which is actually reading data from an external system like Kafka, right? So in this case, there is no buffer server, so that the data can be replayed, and basically the same data can be replayed after a failure in a window. So so this is where idempotency also becomes important for external operators, and we need to implement some logic in this input operator as well. So if we actually see in this example, if this window ID 45, if Kafka input operator had actually assumed that this data tuple 45 was read in window ID 80, then in window ID 81 it would actually emit only the number 32, right? So in the database, what output would be persisted would be 21, 25, 12 and 32, and 45 would not get persisted to the database. So this is so in case if the Kafka input operator is idempotent, all of these records would get persisted in the database. So like I said, the operators which are actually dealing with external world don't have a buffer server, right? So hence we need to implement such logic wherein we can say that our input operators which are dealing with the external world are idempotent. So for this, the platform provides a utility called Window Data Manager. So basically this utility can be used to replay the tuples in case there is a failure and it actually has to process the windows again. So if you for example, if we consider the Kafka input operator, what we can do is that in this window data manager, we can actually, after each window is processed, we can store the start offset and the end offset for the Kafka. Basically, the start offset from where we begin reading for that window, and the end offset till where we read in that for that window. So this information for that window ID is stored to a persistent system like SDFS, so that if this window needs to be replayed after failure, we actually know that in this window we had emitted data from this start offset to this end offset, and it ensures that basically it ensures idempotency for the Kafka operator. Right. So now if we actually see at least once idempotency and operator logic, all of these three actually form the pillars for supporting end-to-end exactly once in Apex, right? So if we actually see without at least once, there is a possible data loss. If there is no idempotency, we could actually have a data loss, as well as we may have wrong output. So like we saw a data loss in case of this Kafka, in this case of this Kafka input to database output example, as well as there could be wrong output like we saw in the case of the max operator, wherein it didn't output the max value. Also, without operator logic, it is possible that there is possible idempotency loss like we saw for the Kafka input operator, and if there is no operator logic which is written in the output operator like databases, there could be possible duplicate data. So that is where all of these three factors become important when we want to support end-to-end exactly one. So the operators which are actually written in Malhar for these external systems actually are, most of them do support exactly one's concept. So you can go ahead and easily use them. Yeah, so in case there are any more doubts regarding this topic, you can always go on to the blog over here. We already have a blog on end-to-end exactly once, so you can always have a read through. There are some other examples as well over here. Apart from that, in case you would like to have a visit, like to view the application templates, you can go to this link, or if you would simply like to download and play around with them, you can directly download uh, from this link. This link is the GitHub link, which actually contains the code as well. Right. So if you want to find out more about Apex, you can always go through these links. So you can subscribe to our community as well as download the Apex code and your meetups link as well. And you can actually view more examples for Apache Apex at the following link. And in case you would like to view the slides for this talk as well as for some of the previous talks as well, you can view the slides on SlideShare as well as watch the video on YouTube as well. It would be uploaded very soon. Apart from that, if in case you are a startup and you would like to actually try out our products for free, we do have a startup accelerator program wherein we provide a license for the DataTorrent enterprise version for free for startups. So you can always contact us in case you would like to have that. Yeah, so that's it for this presentation. So please do post your questions on the questions tab.